Okay, in order to prepare for the keystones, we do need to jump to chapter 11, and we need to know what radical expressions are. The simplest form of a square root expression is when the radicand, and this is a new vocabulary word, the radicand, which is the expression under a radical sign. So underneath here, underneath that square root symbol, this is your radicand. Has no perfect square factor other than 1. The radicand has no fractions, and there are no square roots in the denominator. So the first thing that we need to do is know what some perfect squares are. So right on the bottom, or on the top of your page, some of our perfect squares, because we need to know them. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, so on and so forth. You need to go all the way up to 17 squared, which is 289. Because the square root then of 289 is 17, square root of 256 is 16, 225, and so on and so forth. So the first thing we're going to do is simplify square root expressions. So our first example is the square root of 2 over 50. And the second one is the square root of 8 squared plus 15 squared. The first thing you want to do is you want to treat the square root like parentheses and do inside first, if possible. So the first thing for number 1, I could say, well, I can divide each of these by 2. So I get the square root of 1 over 25. If I look at my list, and I guess we could add 1 on here too, I can now break this up. And I can say, well, this is the square root of 1 over the square root of 25, which the square root of 1 is just 1 over 5. Now let's go ahead and look at number 2. Treat it like parentheses, do inside first. So you get the square root of 64 plus 225. When you add those together, and again, you can use your calculator, you get the square root of 289, which we know is 17. So now let's do a couple more. So this is 3, 4, and 5. So again, treat it like parentheses and do inside first. Let's see if 256 is divisible by 4. So 256 divided by 4, plug it in your calculator, you get 64. So it's the square root of 64, which we know is just 8. Do inside first. 40 plus 9 is the square root of 49, which is just 7. Do inside first. You get 25 plus 144 is 169. So you get the square root of 169, which equals 13. So that wasn't so bad. And again, always keep in mind your perfect squares. You always want to have them with you. Now, we're going to take the product property of square roots. Now notice, underneath each of my square roots, none of them are on this list. But what you want to do is you want to look at your list. Look at your list of perfect squares. And see if 1 is a factor. So look at 72. Can you divide 72 by any of these numbers? And you want to look for a big one. Well, isn't 36 going to 72? Isn't 36 a factor of 72? Well, yeah, it's the square root of 36 times 2. Well, now, I always like to circle it. 36 is the perfect square. Let's take the square root of it. The square root of 36 is 6. We can't take the square root of 2, so it's 6 root 2. And if you plug it in your calculator, if you take the square root of 72 plug in your calculator, you get 8.48 approximately. If you also plug in your calculator 6 times the square root of 2, you also get approximately 8.48. Let's do the same thing with number 2. So I guess this is number 6 for your example. With number 7, let's see if 48 is divisible by any of these numbers. Oh, I can see it's the square root of 16 times 3 equals 48. 16 is a perfect square. The square root of 16 is 4. Can't take the square root of 3, so it's 4 root 3. And again, you can check in your calculator. Now, number 8, you can see number 8, now we have variables. Well, let's think about what the perfect squares would be. Well, x times x is x squared. X squared times x squared is x to the 4th. X cubed times x cubed equals x to the 6th. Notice these are all even exponents. Those are going to be my perfect squares. But if I look at number 8, it's x cubed times y to the 4th. Y to the 4th is even, but x cubed is not. But let's think, x cubed, isn't that really x squared times x? That's an even number. So I'm going to rewrite it as the square root, instead of writing x cubed, I'm going to rewrite it into its factors of x squared times x times y to the 4th. Let's circle all our even exponents, x squared, y to the 4th, and we know we're going to take the square roots of those. The square root of x squared is just x. The square root of y to the 4th is y squared. We didn't take the square root of x, that's the only one we didn't circle, so it's times the square root of x, and that's our answer. Let's try 3 more of these. So we have 9, 10, and 11, and we need to put square root symbols on here. Look at the square root of 128. Is 128 divisible by any of my perfect squares down here? Well, sure it is. It's the square root of 64 times 2. 64 is my perfect square. The square root of 64 is 8 times the square root of 2. And that's my final answer. Number 10, again, we don't have an even. This x cubed is odd. So I'm going to write it as x squared times x. So I know that this equals the square root of x squared times x times y squared. Circle my even exponents, and that is the square root of x squared is x, the square root of y squared is y, and again, we didn't take the square root of that plain old other x. For number 11, now we have letters and variables. 48, we broke apart 48 already, and we already said 48 is the square root of 16 times 3. A squared is just a squared, and b, we can't break b to the first down anymore, so we'll just leave it as b. So we know we need to find the square roots of 16 and a squared because they're my perfect squares. And when I do that, I get 4a times the square root of 3b. Now we're going to put a couple more things together. Now we have a quotient property of square roots. So what you do with the quotient property is you can just simply divide up. We'll just start with number 1 again. With our quotient property, you could take your square root and put it in the numerator and put it in the denominator. When you do that, the square root of 36 we know is 6. The square root of 16 is 4. And when you simplify, you can divide them both by 2, and you get 3 halves for your final answer. The second one, again, let's do the same thing. We get the square root of 80 over the square root of 25. Now, the square root of 25, our denominator, that's pretty simple. We know that's 5. But 80 is not a perfect square. It's not on my list. So let's go and see, is 80 divisible by any number on my list? Well, it is. It's actually the square root of, and you can just start doing in your calculator, 80 divided by 4. Well, that goes into it, but then you get 20, and then that's not quite simplified. 80 divided by 9, 80 divided by 16. Oh, 80 divided by 16 works. It is 16 times 5. We can take the square root of 16, and we get 4 root 5 over 5 for our answer. Number 3, let's do something similar. Put our square root in the top, 18x. Put our square root in the bottom, the square root of 49, y to the 6. And we can do it again. 18 is not a perfect square, but 9 goes into it. So we have the square root of 9 times 2 times x over, well, the square root of 49 is 7. The square root of y to the 6 is y cubed. Equals, take the square root of 9 is 3 times the square root of 2x over 7y cubed. Let's do 3 more of them. 1, 2, and 3. So for the first one, if you take the square root of 12 over the square root of 27, neither one of these is a perfect square, but both of them can be divisible by a perfect square. The square root of 12 is divisible by 4. It's 4 times 3. 27 is divisible by 9, so it's the square root of 9 times 3. So we get the square root of 4 is 2 times the square root of 3. Over the square root of 9 is 3 times the square root of 3. Now remember, when you have something in the numerator and the denominator, if they can simplify, these cancel and you're left with 2/3. Let's do number 2. You get the square root of 36 over the square root of x to the 4th. Well, these work out nice. They're both perfect squares. X over 6 over x squared. Number 3, you get the square root of y to the 6 over the square root of 4, which is just y cubed over 2. The product and quotient properties together, that's essentially exactly what we've just been doing. So go ahead and write down square root of 108 divided by 25. So we know that's the square root of 108 divided by the square root of 25. 108 is not a perfect square, but let's just go through. Let's see if 108 is maybe divisible by, do 108 divided by 16. Nope, 108 divided by 36. Oh, 36 and 3. So the square root of 36 times 3 over, well, we know this is just 5. Take the square root of 36, you get 6 root 3 over 5. You have a simplified fraction. Let's break this apart. The square root of 9x cubed over the square root of 16. X cubed is not a perfect square, so you have to take the square root of 9 times x squared times x, because that equals x cubed, over the square root of 16 we know is 4. Let's circle our perfect squares, and you get 3x times the square root of x all over 4, and nothing can be simplified. 3 more, and I want to jump real quick. We know the square root of 20 over the square root of 49. Well, the square root of 49 is 7. 20 is divisible. They only have 3 options, but we know it's going to be 4 times 5. The square root of 4 is 2 root 5 over 7. Now this one here, x to the 5th, we can simplify to x to the 4th times x, because 4 is even, and it's 1 below. Divided by the square root of 25y squared. The square root of x to the 4th is x squared over 25y